We're going to give it about 2 more minutes here as we have some stragglers coming in. So once we get the last few, then we'll get started. All right, well, I'm sure we'll have a couple more people come in, but just for the sake of time, valuing everyone's time, let's get started. Welcome everyone that's here. Appreciate you being here. My name is Troy Beaver. I'm a partner here at HalenHardy. We also have Karen Hamill on, who's our regulatory expert trainer here at HalenHardy, who's going to be doing the main portion of the webinar today. Before we get started, just giving you a couple housekeeping items to go through, and then we'll hop into the webinar itself. First, we're going to save the question and answer portion until the end of the webinar. So if you do have any questions, go ahead and throw them into the chat feature here on Teams, and we'll organize those. And at the end, we'll try to address them all. If we do run out of time, we're happy to stay on and answer any of the following questions, or if you have to hop out before we can answer your question, we'll make sure that we get you answers to that question following the webinar. Also in the chat, if you want to, please throw in any webinar topics that are of interest to you. We're always looking for different webinars to do for our clients and folks that attend these webinars. So if you do have any ideas or something that we haven't done in the past that you'd like to see, feel free to throw it in the chat and we will try to put something together for you. Next, we're mainly going to be doing this webinar introducing the top, as you can see by the title here, industrial stormwater pollutants, and then the BMPs to capture them. We're not going to go into deep detail on any particular products just for time's sake. But as we're going through the BMPs, just note that these are products that we offer. So if you do have any questions, throw them in the chat and we can follow up after the webinar with more information on those particular products. Finally, if you're having any issues with Microsoft Teams throughout this webinar, we will have this live streaming on our YouTube channel as well. So I don't know, I know technology always messes with me. So if you get kicked out, can't get back in, go to our YouTube channel, or go to YouTube, type in HalenHardy, bring up our channel, and there you'll also see the live stream of this webinar. We'll also be sending out the full recording after the fact to all the attendees, so you also have access to it that way. Finally, before we hop into the main portion, just I know there's a lot of people on here who may not know anything about HalenHardy or very little about us. So just to give you a brief overview of who we are, what we do. Our overall mission here at HalenHardy is to help our customers simplify spill and sediment control. We do that by focusing on 4 core areas. First is spill cleanup and containment in the outdoors. That's anything from cleaning up and containing land-based spills in wet, rainy conditions, to containing and cleaning up spills on water, to products that you can put under persistent equipment leaks in the outdoors. Second core area is filtering oily sheen from stormwater inside of secondary containment structures. If you had the chance to attend our last webinar, we did a webinar mainly on that topic. So if you have questions about filtering oily sheen from your stormwater inside of secondary containment structures, we can send you a link to that webinar that we already did and get you more information on that. Third area, which is mainly what we're going to be talking about today, is filtering sheen, silt, sediment, and other contaminants from stormwater runoff. And that's mainly in and around storm drains, as well as ditches and outfalls. And then the final area that we focus on is dewatering products, and that's anything from large stream crossing projects to dewatering underground vaults or catch basins. So with that, I want to introduce, as I mentioned, Karen Hamill. She's our regulatory expert and trainer who's going to help us through this main portion of the webinar. So go ahead and kick it off. Thanks, Karen.
Thanks, Troy, and welcome to everybody who's joined us today. Today, we're looking at some of the things that you can do to help improve your stormwater prevention plan. So when you look at your organization's SWIP, or Stormwater Pollution Prevention Plan, this is a document that is maintained by your organization that describes how you are going to comply with the different regulations that are set forth under the Clean Water Act. And if you look at the state and local municipality level, they have identified the pollutants that are of concern within their jurisdictions. So they have tallied, they have gone through the different water bodies that are under their jurisdiction and looked at what's polluting their waters. And when you send in a notice of intent to have a stormwater pollution prevention plan and get a permit, they look at those things and they look at what your organization may contribute to the pollution that's in their water bodies. So it's kind of a tier down thing. So you're looking at both the state and the local level as to what might be within a water body and what you might have to do to keep pollutants that are on your property from getting into the waterways. So looking at some of the top stormwater pollutants within the country, I don't want to spend a lot of time reading, if you don't want to spend a lot of time reading your local municipality permits or your state permits or things of that nature, this is something that looks at the top stormwater pollutants that are across the nation. So when you look at the nation as a whole, these are the things that are polluting our nation's waters in general. Now, some may spike in your municipality for one particular area, some may spike in a different area, and there may be pollutants of concern that aren't on this list, but overall, this is what we're seeing that's polluting our nation's waters. The top pollutant is total suspended solids. So this you will often see as TSS. If you see that in your permit, if you see any mentions of that, it's looking at all of those solids that are suspended in water. It can be sand, it can be plastic pellets, it can be a lot of different things. These are the things that will cause water to look muddy. They'll cause water to look unclear. So if you're looking in a body of water or you're looking in a stream and you don't see the bottom of that water body, chances are it's because there are total suspended solids in it. It's also something that you'll notice after a storm, the water in a stream or in a riverbed will look a lot muddier than it does at other times. Usually that's because some kind of earthen material has gotten into that water stream and it's causing it to have that turbidity and look cloudy or muddy on those days. It is the largest pollutant by volume. So this is something that is a problem because when you have a lot of total suspended solids in water, it interferes with the aquatic life that are in that water stream. It can cause problems for the microorganisms that live there, and also the more turbidity that's in water. As that settles out, it can cause problems with the bed of those streams. So when the state and local municipalities are looking to prevent that, they're looking for you to have something at your facility that's preventing those solids from getting into your storm drains or getting into a pond or a creek or a river that might be near your property. The next biggest area is dissolved oxygen. And this is one that has kind of been changing over time. Dissolved oxygen can come from grass clippings, milk, animal wastes, chemicals. Really any kind of thing that you're putting into water that's not a solid can contribute to that dissolved oxygen. It may be listed in your permit as a limit for BOD or COD. The difference between those, BOD stands for biological oxygen demand, and biological oxygen demand measures the oxygen demand from microorganisms that are in the water. So there are different microscopic bodies within the water that need oxygen to survive. And those microscopic bodies are what the fish and other culture that are in the water eat. So if you've got chemicals or something else in the water that's taking that oxygen, it's starving those microorganisms, and they're not able to be in that food chain for the fish and the other fauna that are in the water to eat. Chemical oxygen demand is similar, but it's measuring the dissolved oxygen that the water needs to oxidize any organic chemical or any organic body that is within that water source. So in some municipalities, they're looking more at BOD, and some they're looking at COD. It's kind of changing over time. BOD is something that they used to focus on, but now they're kind of looking at that chemical oxygen demand as the bigger picture of what's in a water system. So when you see those within your permit, it's having to do with something that's getting into the water that is causing a problem for the organisms that live in that water body. Dissolved oxygen often comes from nutrients, and nutrients are things like nitrogen and phosphorus. They're things that are found in a lot of the organic materials in nature today. So this again could be from grass clippings, or it could be from food sources. It can also sometimes come from chemical sources, but these are things that are typically going to contribute to any kind of algae bloom that might be within your water body. It could also be something that causes cloudiness in your water. Sometimes a nutrient overload in the water can even look like an oil sheen on the surface. So if you have any of those problems, if you have a retention pond or a detention pond or a nearby stream or something that has that cloudiness or a lot of algae in it, it could be due to an excess of nutrients within that water body. Again, very closely related to that BOD or COD that might be in your water. Another big problem for water bodies is metals. And you see the list of metals here. These are all considered heavy metals. And if you are testing your water source, you may have a T-clip test that often identifies these different metals that might be within a water or a waste stream that's coming out of your facility. Metals are a problem because they tend to bioaccumulate in fish and other fauna and things that live within that water body. And that's a problem because then when we eat the fish, we're ingesting those things into our system. Another problem with metals is that they can be carried along by any solids that are in the water body as well. So if you're releasing any kind of dirt or debris, the metals tend to attach to those and be carried along. And they are something that bioaccumulates within your water body. So they kind of lay in the bottom of the stream or they lay in the bottom of the pond, and they don't really dissipate. They're not like an oxygen depriving substance that is going to clear up after time. They're just going to stay there and linger, which again causes problems for the fish when they eat it. It can also cause problems for the fish in the form of tumors and lesions. So it's something that not just is within the body of the fish, it's something that is going to cause problems for them in their reproductive health and also with the fish itself. Hydrocarbons, including oil and grease, the chemicals that you see here, pretty much anything that makes a sheen on water is another major problem. And the fact with this is it doesn't come from large spills. So when we hear about those big spills on the news, like the BP disaster or the Exxon Valdez, those things don't happen very frequently. In fact, they only happen maybe once in a decade, maybe a little more often than that. But where you're finding the hydrocarbons that are getting into the water, they're typically coming from small leaks and drips that happen on land. So this could be overfilling a tank or overfilling a container, that leak or drip that's persistent from a pump that hasn't been able to be maintained in your preventative maintenance schedule yet. All of those little things accumulate and get into storm drains, get into our ponds, our rivers, our streams, and accumulate there. And the reason that they're a problem is that it takes some time for those refined oils to dissipate into nature. Nature can take care of a little bit by itself, but when we're contributing regularly to those oils getting into the water basins and into our streams and rivers, it causes problems that can stem from having an excess of those algae blooms coming into the water. It can cause the vegetation that's along the edges of a stream or a pond to just decay and rot and die. So a lot of problems can be caused by those hydrocarbons. So the more that we can do to keep those from getting into storm drains, into our streams and rivers, the better the stream is able to take care of itself. Temperature is another one that is not quite as common as the ones that we've talked about this far, but temperature is a problem for places where an industry or a facility has some kind of a cooling issue. So if they're using water to cool their process and they don't take the time to let that water reach an ambient temperature and they release it before it reaches the ambient temperature, it can cause problems for the fish and fauna as well. Some indicators that you might see here are if you look downstream from where your water is discharged, and you'll notice that there's kind of a line or an area that looks different. Maybe the green is different. Maybe flowers grow in one part of it and not in another part of the stream. Those can all be indicators that a temperature difference is happening within that water body. It can also affect, just like the other things that we've talked about so far, it can affect the microorganisms that are able to live within that water body, as well as the type of fish that can be populated and live in those areas as well. And temperatures as little as 5 degrees in fluctuation can cause problems. So fish aren't quite as adaptable as we are to those temperature fluctuations. So we need to be aware of any time that we do have those cooling waters or waters that are at a higher temperature than the receiving bodies. This can even be true for facilities who are doing maybe construction activities or wash down activities in summer months when the temperature on the surface, on a paved surface, is very, very warm. And if you release that into the water body that is cooler than that, it can cause those seasonal problems as well. So that's a look at the top 10 pollutants within industry. And as I mentioned before, there are a lot of things that may not have been mentioned that may be of concern, and often it will come down to your local municipality and what they specifically are looking for and what they need to keep out of their water bodies. So check out your permit, check out your SWIP to make sure that they match up and that you may and that you don't need to alter any of those limits to make sure that you're in compliance with what your permit requires. So there are a lot of things that you can do to help keep pollutants out of the water stream, out of the waters, bodies, ponds, streams, rivers, lakes, oceans. And they all come down to best management practices. And best management practices, when you look at the EPA's definition of that, the definition is very broad. So most of the best management practices are focused on preventing pollution from getting there in the first place. So looking at your procedures, looking at your policies, looking at what you do to prevent something from getting into that water stream. And usually it takes a combination of best management practices. So one thing may not be enough to solve the problem. So this could be, let's say that you've got a fuel dispensing station and you've got a 1,000 gallon above ground tank that you use to fuel all of your equipment. It could be having a policy that you stop the engine, chock the wheels, and you clean up your leaks and drips. Policy is great, but maybe you also have an engineering control in place that you have level indicators on your tank so that you know if anything has leaked. And you also have a spill kit available so that if something does spill, people are able to clean it up quickly. So it's that combination of things that is going to help collectively to keep things out of the waterways. There are basically two types of BMPs. There can be structural BMPs, and structural BMPs are things that are installed or engineered or constructed. So this might be something like a detention pond or a secondary containment system, constructing a wetland that allows you to infiltrate your water into that and settle before it is released into a stream or a river. It might be an oil water separator. It's something kind of structural or something in place that is going to help you permanently take care of pollution that might enter the environment. Non-structural BMPs are things that are more mobile in nature. So this could be having the spill response supplies ready, having a spill kit that's mobile and ready to go, having your procedures and policies in place, conducting training so that employees know what to do when they do have a spill, or they know how to handle things so that they aren't having a spill in the first place. All of those non-earthed materials that might be in place are considered non-structural. And as I mentioned, probably going to need a combination of them to help keep all the pollution from getting into the waterways. So one of the first forms of best management practices is good housekeeping. And good housekeeping practices are something that will help you if an inspector does show up at your facility. If you've got your facility in order and you're doing your part to keep your area as clean as possible. Now, it doesn't mean that it has to be a medical facility level of cleanliness, but if you've generally got your house in order, you've got lids on your containers, you've got secondary containment where you need to have it, your facility generally looks clean and ready for business, that can really help you in an inspection. And it shows that inspector that you're doing your part, that you are making an effort to keep pollution out of the waterways and keep pollution in its place. Another important thing is to incorporate the practices, good housekeeping practices, into your daily routines. So this might mean getting them into the job descriptions, because especially if you're working with unionized labor, it can be easy for them to say, look, I don't have to clean this up. That's not in my job description. That's somebody else's job. But when you incorporate it into those job descriptions and you make it part of someone's daily duty, then it is going to be something that is ongoing, and it will help keep you from having those workplaces that are disorganized. It can also help with production schedules, because if everything's in its place and there's no clutter and there isn't a lot of junk around, it can be easier for them to find the things that they need to get their jobs done. So some practices can be as simple as sweeping up the lot when you're done, having drip pans underneath anything that leaks and drips so that you don't spend a lot of time looking for your spill kits to clean things up. And it can be having preventative maintenance schedules, all of those things collectively that are going to help keep your workplace looking good and allow people to do their job as well as they can. FIFO, if you're not familiar with that stands for first in, first out. So looking at using your chemicals in the order that they have arrived and making sure that you don't exceed those expiration dates. So you don't end up using the new drum of oil and the old drum of oil has been sitting there for 3 years and has now expired. Next is making sure that you've got a plan, a schedule, an inspection schedule, a storage schedule, a rotation schedule for those raw materials. Making sure that these things are in check. So in this picture, this is a salt pile, and you can see that it's covered with a roof and it's got some sidewalls on it. And those things help to prevent water from dissolving that salt and allowing that salt to get into a waterway. This could also be a picture that might show a pile of sand or a pile of small shale. Any of those loose materials that you may have, keeping them under cover. If you don't have the ability to keep them under a roof, keeping them under a tarp, making sure that they are not being washed away whenever a rain happens. It can also be having secondary containment systems. And the secondary containment systems could be used for loose piles, could also be for any storage of liquids that you might have on site, so that if a container would happen to leak, it's contained and it's not going to travel to the nearest drain. It can also be a matter of having an inventory of the materials that you've got on site so that you know what's there, what can be used, and also what has the potential to spill, and keeping containers labeled so that you know what you've got and people aren't misusing something inadvertently. Similar to managing your raw materials, have something in place, have your policies and procedures in place for managing your waste. Now, this can be solid waste, or if you do also make hazardous waste, having those waste streams identified, keeping them segregated, inspecting them as needed, providing secondary containment where you might need it, having all of those procedures in place, keeping your inspection schedules in line, and having those plans that are going to help you to manage this waste and again, keep them out of the waterways and make sure that they're processed in a timely manner. not a lot of the construction slurries are not only for construction permits. And we see a lot of companies who may be refurbishing a facility, modifying a facility, demolishing something. When those things happen, when you disturb concrete or you're disturbing asphalt, you can create a lot of dust. And there's a lot of focus now on containing and controlling that concrete dust. Because of course, if you let it get into a water stream, that's a solid, it's a TSS that is contributing to a lot of problems. And again, something that just kind of settles into that water stream and doesn't allow the fish and the fauna to have the nutrients that they need from that soil. So it's not difficult, and also it's not difficult to track where concrete slurries are coming from. So if you do happen to have a construction project that is within your facility or your organization, make sure if you're doing the work, control that slurry, keep a sock down, have something to dewater that, keep that concrete from getting into your storm drains, or work with your contractor that is doing the construction. Make sure that they've got procedures and policies in place to keep that concrete dust from getting into the waterways. Similar to that, dewatering. Dewatering can happen with a lot of different types of processing waters or slurries. If you're pumping out a vault, anytime you've got a lot of water that can have some kind of solids in it, dewatering can help you to keep those solids from entering the waterways. And it could be, in the picture here, we're showing a dewatering sock, and basically this just goes over the end of the hose. The water is able to filter through, and it's going to collect any solids that might be in that water. These can be a lot larger than this. I have actually seen dewatering bags that are 100 meters long. So depending on the volume of water that you need to move and the amount of solids that you might have within that water, dewatering is a way to just help keep that solid count from entering the waters. Another neat thing about dewatering is, depending on the kind of filtration that you need, it can also help you filter out metals or sediment or nutrients. There are a lot of different things that dewatering products can do to help keep different types of pollutants from getting into waterways. The next idea, this one takes a little more engineering that might not be in everybody's budget from the start, but diverting stormwater to swales. You can also divert it to vegetated areas, detention ponds, retention ponds, areas that have a lot of grass growing in them. Anytime you can divert stormwater to a vegetated area, it allows that water to infiltrate into the ground. And that's advantageous because it keeps it from going directly into a stream, and it allows nature to kind of have that energy back from the water. It also gives you a second chance to contain spills. So if you can divert any stormwater that you've got to a specific area, it gives you that opportunity to, if you didn't catch it on land on a paved surface, it gives you the opportunity to catch it within whatever area you have diverted it to before it gets into a stream or a river. So it may not be quite as easy to control a spill that's on land as it is to control it in a detention pond, but certainly a lot easier to deal with it there than when it gets into a river or a water body. Managing nutrients, this is something that you may need to work with maintenance crews, or if you have landscapers that come onto your property to handle your grass cutting or your seasonal maintenance, having them apply fertilizers at the right time and having them applied correctly is important, because when there's overspray from fertilizers or when they're applied too liberally, they get into waterways and they cause those problems with the algae blooms within the water. So having a plan or a practice or a policy procedure to manage those properly, apply them at the right time, keep them away from water, is important to help prevent those blooms. Oil water separators can be a powered system that is put into place. That can be a structural item. So if you've got a process where you're doing a lot of washing of parts or cleaning of parts, maybe a fleet maintenance system where that oil and water are both kind of part of your system, oil water separators can help prevent those hydrocarbons from getting into the water. So they can be a passive, they can be a system where you pump everything through an oil water separator, or it can be something that's a little more passive and you do it by the batch. But just a way to keep those oil and often sediment from getting into any water that is released. Fuel dispensing areas, and also I'll add into here fuel transfer stations, anywhere that you're moving liquids provides a big potential for spills, leaks, and drips. So looking at these areas, this is a good area to label and make sure that people know the procedures for dispensing or transferring any fluids that you might have. So here we have a fuel tank. This could also be maybe an area where you dispense and transfer your hydraulic fluids. Maybe it's an area where you're collecting your waste oils for recycling. Whatever that is, anytime you're moving liquids between a container or a tank into a vehicle or equipment or into another container, that is one of the biggest potentials for spills to happen and for leaks and drips to happen. So train your people on what they can do in those areas to clean up those leaks and spills quickly as they happen. Don't let them accumulate. Don't let them get into the ground where they're harder to take care of a month or two down the road. Having the ability to clean this up properly, that might mean stocking absorbents in that area. Maybe it's keeping wipes in that area, whatever it happens to be, so that they can take care of those things as they happen. Another thing that you can do in these areas is provide secondary containment. So if there is a large scale spill, it has a defined area to be in as opposed to heading to the nearest drain. When you've got, when tools and machines break down, they tend to release fluids, and those fluids tend to be oil or petroleum based. So having a preventive maintenance schedule can really help you to prevent those breakdowns from happening. If you keep your hoses in good condition, keep your machines and your tools and everything in good working order, and you're routinely looking at those things to make sure that they are still serviceable and still working within the parameters that they're intended, that can help you prevent those leaks and spills that happen, those leaks and drips and problems that happen when something does break down. Can also help you with your production schedules, because if things are breaking down and you're not planning on it, things can tend to get behind. So having that is sort of a best management practice on many different levels, not just from a stormwater perspective, but keeping everything in tune so that you don't have those unpredictable time offs. If you have hazardous waste on site, you're probably familiar with the requirement to keep your containers closed. It's a requirement because if a container is closed, it's less likely to leak or spill if the container gets tipped over. Still a best practice for any type of container that has liquids in it. So whether it's a hazardous material or even just something that maybe isn't necessarily hazardous, but could be a problem when it gets into a water, just a good general practice to keep every container closed when you're not using the liquids from it. It'll help you preserve your chemicals, help minimize the amount of waste that's generated, and help keep everyone from misusing those containers as well. The next best practice is to guard your storm drains. Storm drains are sometimes your last chance to capture sediment, pollutants, hydrocarbons, metals, nutrients before they get into a water stream. So if you don't have a facility that is set up to channel your stormwater into a detention pond or a vault or some kind of an area that it has a place to settle out, this can be your last chance to grab it before it gets into the environment. So looking at ways to kind of last guard those storm drains is important, and something as simple as having a stormwater filter that is in place will help you capture those things and minimize the amount of pollutants that are getting into the waterways, especially when you're looking at TSS, those solids, and hydrocarbons kind of being those top priority chemicals getting into waterways. Having something in place that allows you to grab those before they get to the bottom of the storm drain or before they get to the discharge point will help prevent that pollution and make it a lot easier for you to clean up things before having to enter a water stream to do so. preparing for spills, a lot of the focus is correctly on preventing spills from happening in the first place. So looking at the best management practices that we have discussed so far, those are all proactive things that you can do. So having those plans in place should help prevent the spills from happening. But we all know that Mother Nature can have her own way. Storms can cause things to happen. There are a lot of different reasons why spills happen. And we can't always predict them. So the best thing that we can do is be prepared when they do happen so that any employee who has been trained can take immediate action to clean up a spill so that it doesn't reach a waterway, so it doesn't hit a storm drain, so that it's not getting into water tables or wherever that spill may happen to go. Having the ability to quickly respond can mean the difference between having a spill that is just kind of a nuisance and a pain to clean up on your land, or having something that is reportable and causes that big permit violation. So look to stock your spill kits anywhere that you've got fluids. So if you've got mobile fleets, those fluids move with you. Keep a spill kit on your truck. If you've got large tanks, keep them where the tanks are. If you've got secondary containment areas where you're storing raw materials or waste materials, have a kit in that area. Wherever you've got those liquids stored and transferred, or where you've got those fleet vehicles, have a kit handy so that people can take action to guard drains and get that spill under control. And it may be a situation where they can kind of stop it until your emergency response team gets on site. Those little efforts can really pay off in the end. Having pollution prevention teams, it's almost impossible for one person to try to handle all of the spill response and environmental needs on their own. So having those extra set of eyes in the field and having a diverse team of pollution prevention people who have been taught to look for different ways to form best practices, to look for opportunities where you can prevent pollution, having those extra set of eyes can really be a benefit to you to make your plans better and make your plans stronger so that you don't have those discharges that could be a problem for your facility. And also, pollution prevention teams are something that if you're looking at your sustainability efforts or your ESG efforts, that's something that stockholders and shareholders will look for because it shows that you have that proactive mindset in helping prevent pollution. And finally, training and education. Training can take a lot of different forms. You see a couple of them listed here. Training doesn't always have to be an hour-long lecture or a day-long presentation. Focus on what people need to know and demonstrate how the BMPs that are in your plan help them with what they are doing throughout the day. Show them how these BMPs will make their jobs or their tasks easier, and incorporate that into your training and education so that it's not just we're doing this because we have to, because a regulation says so. Show them how it is actually going to help them, not just with their day, but also with your corporate efforts to be sustainable and to protect the environment. And with that, I'd like to turn it over to Troy to see if we have any questions.
Thanks, Karen. That was great. Yeah, guys. Any questions from those of you in attendance? I see Kevin had thrown in here. How can I get a certificate of attendance showing credit hour? I'll throw this in. We can send this out.
Troy, we can't hear you.
Sorry, I was muted. Well, I just talked for 5 minutes, but I'll try to give you that time back. So yeah, thank you, Karen. Appreciate that. The first question I have in the chat here is how can I get a certificate of attendance showing credit hours? We may not have the email address that's showing up here whenever you signed into Teams. So if you don't mind, just go ahead and throw client success, an email to clientsuccess@HalenHardy.com. I just put that in the chat. And then that way we can shoot you over a certificate showing your credit hour. I know sometimes people, the email that we may have on file for you when you sign into Teams may be a different email. So if you don't mind, just send us an email there and we'll make sure to get you that certificate. Looks like we have one here: reiterate best practices for wind-blown particles, dust, metal, wood shavings, cure or herbicide overspray, etc. I'm guessing you're talking obviously not just mixed with stormwater, but the way to prevent those from spreading via wind. Karen, I'm sure you have keeping stuff under roof, obviously contained as best as possible inside of closed containers, things like that could definitely be a BMP for preventing particles to be blown around by the wind. Karen, any others on your end?
Another one would be to, depending on what the process is and depending on what's blowing, look for any kind of a wet process that might be used. So if it's something that's creating a lot of dust, maybe from a tool or a machine, often those can be fit with some kind of a sprayer on them that helps to basically knock those particles down. Now it's going to kind of create a sludge for you to deal with, but the sludge is something that is a lot more easy to deal with than particles that become airborne. Sometimes screening can be used if you have the ability to isolate that process. Kind of think of the way welding is done. It's kind of done in a certain area to make sure that any welding sparks don't get out. Kind of the same principle there. Look for a screening material that might be able to be put around the process. If it's something outdoors, I know that can be difficult, but I've seen a lot of wet processes being used to help minimize that airborne dust particulate out there. Depending on what you might be doing, that might be something that's advantageous for you. That can also be a good safety feature as well, because if that airborne dust is being knocked down, it doesn't get into people's breathing and causing lung problems down the road as well.
Next question: considering the dewatering slide, would the filtration sock be an effective control for shop air condensate? John, we have used it for similar applications before. The filtration husky material that the sock is made out of allows water to pass through. It's going to hold on to hydrocarbons. So when dealing with condensates, depending on the concentration of condensates that you're pushing through, if it's just a light mist, yeah, it'd be a good job to allow the air to still pass through, but capture any of the condensate that's coming out. Also, I'll mention, I know you're not talking about the micron size, but when it comes to suspended solids, it does filter down to 53 microns as well. So it has a good filtering capability on that side of things. Ed asked, any experience with MS4 stormwater permits that require phosphorus reduction in sensitive watersheds, for example, Florida, Lake Erie? I can talk on the product side of things. We do have some sponge media that is engineered to work on phosphates. I'm not sure on if that would include the phosphorus side of things. We are working on some stuff for the bacteria side of things as well. But I'll have to follow up with you after the fact on that to get a little more info on what you're talking about with the phosphorus reduction. Karen, I don't know if you had anything on your end.
Just echoing what you said, there are some sponge media, flocculants, things out there that can help with that can be incorporated into different products that we have.
Yep. Well, that's all I'm seeing now in the chat. Again, if you have any additional questions that you didn't throw in the chat, client success at HalenHardy.com. If you want to shoot an email to that, we can get you more information. I think, Karen, is there a following slide with contact info or?
Yes.
Yep. there you go. You can email Karen or myself. That's my cell phone on there. So call or text there. Ed, I will follow up with you on the phosphorus reduction as well. And there's client success at HalenHardy. So, well, I appreciate everyone taking the time. We'll give you 14 minutes back of what we promised. So do something good with that today. And we appreciate you being on, and we'll keep everyone on the loop on our next one. If you have any topics that you'd like to see again, go ahead and shoot that to client success at HalenHardy. We appreciate it.
Thank you.